Hello, today we are doing some more measurement. We're going to be looking at area in particular. Please set up your book on a new page. Draw a line with a red pen down the centre. Put the titles in and underline them in red and today's date. Our WALT for today is to use the correct formulas for the area of 2D shapes. Please write that in. Why do we learn about measurement? Because it's important in many aspects of life. You need it for many professions and jobs. Those are just a few: designer, dressmaker, an architect or builder. Many jobs require some form of measurement. Today, as I said, we are going to be looking at area. So you don't need to write down all those titles. We will go through all of those individually. Okay, please write down this information, however, that the area is the amount of flat surface enclosed by a shape. We are looking for how many squares could we fit inside that shape. So it's measured in square units, square millimetres, square centimetres, square metres, square kilometres. Have you noticed we say square millimetres and write it this way? Okay, millimetres squared is a different concept. Here is the chart. Now you'll see that we don't have to learn new conversion factors. From metres to kilometres is 1,000, but remember we're multiplying two units together, so we need to square that information. And again, when you move from a larger unit to a smaller unit, you need a bigger number. You will need to multiply to get the bigger number. If you go from the smaller unit to the larger unit, smaller number, you need to divide to get that. Remember, we looked also at hectares, HA, because it's hecti, and airs. It's 100 times 100 metres, or 10,000 square metres. Now here's an example for your metric conversion. So please copy down what's in the blue over here, and this is what you would be thinking as you are doing it. So the first one, you're moving from a larger unit to a smaller one. Smaller unit, bigger number, we need to multiply. Now there are 1,000 metres in a kilometre, but you will need to multiply by 1,000 times 1,000, which is 1,000,000. Moving your decimal place along and then filling in those empty spaces with the zeros. You end up with 81,000 square metres. The next one, from a smaller to a larger, so the number must get smaller, you need to divide. We had worked out earlier that there are 1,000 millimetres in a metre, 10 times 100. We need to square that. Okay, copy those down. The first area we're going to look at is a rectangle. So the formula is length times width, the L is length and the W is width. Square, because all four sides are the same, it's just the length squared. So copy down particularly the highlighted parts, please. Here is your worked example. So always write down your formula. That's a rectangle. So you write down your formula for rectangle, length times width. You now need to substitute. So your length up there is 8 and the width is 5.6. So you need to substitute them in where the letter was into the formula. Get out your calculator and find your answer. Remember, you must put in your units for your answer. The next example we're going to do is the triangle. Triangle is a half of a rectangle. You could build a rectangle around that, which would have that length and that width, but the triangle in the middle is only half of it. So it's base times height. B is the base, height is the perpendicular height. That little square there tells you that the base and the height are perpendicular or 90 degrees to each other. The example, this is the first one, A, and you'll notice they're both in centimetres. They've written the formula, they've substituted into the formula. The rest of it's on the next page. Okay, and they've used their calculator to get the answer. These were the dimensions on that second one, but you noticed, hopefully, that they were in different units. So one's in centimetres and one's in metres. The first thing you must do is convert them. And it says here to the smaller unit. So in the question it's asking you to go to the smaller unit. So you'll need to convert the metres into centimetres before you can continue, because you have to have the same units when you multiply them. So the answer is square centimetres. They're both in centimetres. The next shape we're going to look at is the parallelogram. Now, squares and rectangles are special parallelograms. It just means it's got four sides, two pairs of parallel sides, and each pair of parallel sides has equal length. You can see that because there's one arrow here and here, and there's two arrows here and here. If you then cut this piece off here, you could put it over there and you would see that you now have a rectangle. And so you could go base times height, which would be its length, times its width. And yes, that is the formula. So remember, the area of the triangle was a half. However, the area of a parallelogram is base times height. Still the base times the height, because we're looking at the perpendicular height. In a rectangular, that perpendicular height is its width, of course. Okay, so this is your formula that you need for a parallelogram. And a worked example, straightforward. Put in your formula, check your units are the same, substitute them into the formula, calculate the answer, make sure you include your squared units in the answer. Okay, rhombus and kite. They actually have, as you might notice, the same formula. A rhombus, it's also a parallelogram and a quadrilateral. All four sides are equal length like a square. However, it's a square that's leaning on its side. And the opposite sides are parallel and the same length. So we actually multiply the diagonals. So the diagonals are the things that go from straight across the middle from point to point. And we halve that. Kite is the same, except it's got adjacent sides the same, 1, 1, and 2, 2. Again, we multiply the diagonals and we halve it. So same formula, diagonals. Okay, now for some examples. If you go into your Jack Plus, you'll notice that it has this when it has the examples. You really need to know these ones here. These are your C's. So you really need to know them. Now, first one here, we are going to complete the following metric conversion. So we'll do the first one as an example. It has asked you to convert 0.53 square kilometres to square metres. Now you know that's going from a bigger unit to a smaller unit. Going to a smaller unit needs a bigger number. To make a bigger number, you need to multiply. There are 1,000 metres in a kilometre. We need to square the 1,000 to a million to make the conversion for square units. There are 6 zeros we need to move, 1, 2, 3, 4, 5, 6. And so we've got the 5 and the 3 stay together, and 1, 2, 3, 4 more zeros, making 530,000 square meters. Okay, now you have a go at the rest of those. Here are your answers. Check your answers, and if you've made any mistakes, go back and see what you can do to fix it. Moving on to question 2, and it's showing you some rectangles, and we're going to find the area of those rectangles. So, second example, as per what we did, you need to write your formula. So rectangle is length times width. We substitute from our diagram. So the diagram said it was 9 times 4. We used our calculator. It was in centimetres, so it's square centimetres. Okay, now you have a go at the other two. And there are some more on the next page. Okay, so have a go at those, and the answers are here. If you've made any mistakes, go back and check your answer to see what you've done wrong. Okay, questions 4 and 5 is related to this diagram. Now this is what often confuses students, is there's extra numbers here. All of those numbers there belong to the measurements of that one there. And it's asking you the base and the height respectively on the triangle R. So we're looking at the height and the base. So the base is always this big one down the bottom here. It might not be on the bottom. And whatever is the height, you'll find this little square. So we're looking for where do we have two measurements that come together at a little square. So the height is this one and the base is that one. So the height we know is the 32 and the base is the 187. So the answer here would be C. You don't need to worry about those other measurements at this stage. You would only need these three measurements to find the perimeter. So you would add these three measurements for the perimeter. You wouldn't need that one if you were doing perimeter. And the area, so you would now need to multiply the 32 by the 187 to find the correct answer. If you work that out, did you get B? If you didn't, try again. Now 6, we've got our triangles. Now as you can see, sometimes the perpendicular height is outside. That doesn't matter. Sometimes the base is not, it's not sitting on the base, it's sitting on one of the sides. That does not matter. The formula says that you have to do the base and the perpendicular height. Look for the little square. The two measurements running along those little squares, that's all you need to worry about. And in this one here, you can see that that measurement and that measurement are the same, and there's your little square. So you would just need to square that number, wouldn't you? Let's do an example together. So remember, triangle, it's half the base times the height. So you need to halve that base and height, perpendicular height, the two measurements that meet at a little square. Use your calculator. Make sure that you have squared units. Here are some for you to try. Have a go at these. And your answers. If you got any wrong, please go back and check them. You'll probably find it was just a simple error. Here we've got our parallelograms. Remember we went through those and said it's very similar to your triangles, except it's not half, it's the whole thing. So we've got measurements meeting at the little square. Don't worry about any other measurements on the outside. Just find the two that meet at the little square and use those. Sometimes you have to look a bit hard to find them, sometimes they're outside. You just have to find them. Okay, let's do 7 together. Remember, it's the base times the height. Same as a rectangle, length times width, except we don't do the width, we do the perpendicular height. We checked they were both the same unit and we multiplied them. Square millimetres. You must include your units when you're finished. Okay, and the last example is for rhombuses and kites. Remember they had the same formula to do diagonals, and we had to multiply the diagonals and halve them. So our last example, multiply the diagonals and halve them. The diagonals go from corner to corner. Make sure you include that. Okay, some extra work for you to do. Have a go at the rest of those that are to do with parallelograms and rhombuses and kites. And here are your answers. Well done.